Hey brother, what's up? It is currently the 16th of October, the year of the Lord 2016. That's a lot of 16s. And today is Summary Sunday, where I go over what I did this last week, which isn't a whole lot, but hey, we'll take a look at it anyways. I'm going to switch over to the desktop mode here and pull up my IDE as normal. So this week I spent a lot of time working on the merchant algorithms. And I got a little carried away on the theory part of this and planned out a bunch of stuff that I'm never actually going to do. However, I did make a little bit of progress, and I found some key places where I need to refactor. So one interesting thing that I added was unit tests. These are little tests that get run when my code compiles, and they test my game logic to see if it still works. So I've got a lot of tests for the merchant, or well, really 5 tests right now, but it's going to be quite a few, and it tests different parts of the algorithm. So for example, the merchant has a function that returns whether an offer is profitable, and I want to make sure that that lives up to its expectations, and I've put in a bunch of tests to test different rules. For example, the test is profitable if the value that the player is offering is greater than what they're asking for from the merchant, at least from the merchant's perspective. So when I'm setting this offer where the player is offering 3 items that have a value of 5 for 2 items that have a value of 5. That is a 50% profit for the merchant, and so that's profitable, and the test passes. So I can actually run this again so you can see. So it's going to run. It's only going to run the one. That's lame. That's not what we wanted. We want to run all of them. There we go. So you can see one of my tests is not passing. So I checked for identical offers. Identical offers aren't profitable. If you offer the merchant something that is the exact same value, they're going to say, hey, that's not worth my time. I may remove that one as a game mechanic, and what I would do then is I would flip the criteria to say, hey, if I give you an identical offer, you should say it's profitable. And so then I see whether my test passes or not, and all of that. So the complete offer method is the new version of the method that gets called when the player sends half an offer. So let me actually see. Everything should compile, but hey, I'm doing this on camera, so you never know. So yeah, when I pull up the game and go to the trader, I can offer something like this glurf bonsai bush, and ask the trader what he'll give me for it, rather. And so I'm really making an incomplete offer, and the merchant has to complete it. It can work the other way. I can say, hey, I want this thing that you have. What do you want in exchange? So this whole completing the exchange piece of it. And so I'm starting to put in tests for that. I am refactoring it. We'll take a look at the data model in just a second here. But the cool thing about these unit tests is that they act as the specs for my game. So one popular way of programming is called test-driven design, which is where you actually write your unit tests first, and then your code is considered working as soon as that unit test passes. And the idea is if all your tests pass, then you've built what you want. If you can't put what you want into a test, then you've got a problem. Some people are more draconian in this than others. I typically I think that this is a place where you can get into sort of a testing paralysis, where you need to say, okay, I need to have a test case for everything that could possibly happen. And that gets really hard when you're testing like how things render or working with third-party libraries. It's definitely worth the effort. It's something that is good for you to look into. I know C# has an equivalent, but it's the goal is to make usable software, not to make usable or running tests. So you have to. I think you have to have a balance. But I added these, and I'm going to be adding them for now just to make sure the trading algorithms work, so I can have different tests for different scenarios and make sure that as I make changes and make it more complicated, the basics still work. So, and it beats having to open up the game and testing each scenario by hand, which was kind of a pain to do. So that was cool. The other thing I'm doing is refactoring my classes. So I'm going to pull this sucker over here. This is a program called Draw.io. It fits, it slides in nicely to Google Drive, and it allows you to create diagrams. And this helps me to illustrate some of the more abstract stuff about my game. So I'm going to tell a little bit of a story here. In my previous versions of the game, I had several classes, and this is how items were represented. So my first class was an item type. Only one of these suckers gets created per item type, because the information around the item type, like what is its picture, what's its description, that stuff doesn't change. I always describe a type of an item in the same way. This could have been done with enums, but by making it a class, it allows me to load it from a file, which is cool. So that's what I did. Now, an item type has a bunch of fields. I'm only going to list a few of them, but it's got a value, a base value. This is what the merchants use, and it is a float. It's got, a name, which is a string, and the description, which is also a string. And so you can see it's got a lot of information in it. And it doesn't have, I don't think it has a lot of thinking methods. It's more just store data. So this, by the way, this notation is called UML, Universal Modeling Language. It is used to try and draw classes. It's an industry standard. It'd be good for you to learn. I think you'll pick this up in like CS 350 or 360, somewhere around there. So if you learn now, you get a head start on it in school. Anyways, my item type was associated with an item. And this is where things didn't go so hot. So an item had a type, which, as you might have guessed, is an item type object. And it had a quantity, which was an integer. And so my item, where did they hide the arrows? My item was related to my item type, and I think hollow arrow means, or hollow diamond, I should have looked this thing up before I started recording, but essentially what I'm trying to show here is that an item contains an item type, but the life cycle of the item type is not related to the item. So if my item gets destroyed, say you run out of, your quantity gets to 0, I remove that item object off of the merchant or the player and destroy it. But the item type still stays alive because there's only one of them, and it describes a whole category of items. So this is a little funky, but I needed a way to tie the quantity to the item and say I've got this number of this type of item, and if I put the quantity inside the item type itself, then I would have to create a different item type for every player or merchant that had that item type, if that makes sense. I would duplicate a lot of information. It's not so bad in this game because, maybe you have 1,000 merchants, and that's okay. If you are working with a game like Minecraft where you've got voxels, where you've got those little blocks of terrain, then you have to be really careful. Or if you have bullets, you're shooting thousands and thousands and thousands and thousands of bullets, and just spraying lead everywhere, you don't want every bullet object to have a lot of information tied to it, right? So, you only want what can change. So I started doing this. I didn't draw it out very well, and so I'm changing it now. So to complete this picture, we have an abstract trader. Name could have been better, admittedly, but this is the base class for both the player and the merchant. They both extend or inherit from this class, or extend it, and get a lot of the inventory management stuff from it. So what this had was an array of items. Whoops, I flipped it. Inventory, which is an array of items. If you're looking at this, if this looks a little bit funny and you're thinking arrays don't look like that, it's because it's not a Java array, so to speak. It is a special array class created by libgdx that has some optimizations. I'm not going to go into a whole lot of detail around it, but suffice to say, it's we can think of it as an array. Now, let's see, this is composition. So if I got that right, composition versus aggregation, and I think I did, the item's life is tied to the abstract trader. So when the abstract trader gets destroyed, so do the items, but the item types do not. Anyways, this is kind of cumbersome, so I'm going to be refactoring it. And I'm saying, you know what? My item type is good. I'm going to keep that. My abstract trader, I can't really get rid of that. Bad things will happen. But this item's clunky. So what I'm going to do is I'm going to, instead of having an array, I'm going to have an object map. And it is going to be of item type quantity. And the, I can spell quantity, just you wait and see. There we go. Make this a little bit wider. There we go. Okay, so my, just make it super wide. There we go. All right, so now I've got this relationship between my abstract trader and my item type, and I've eliminated this item object. So when we look at this from a code perspective, right, in order to get an item from the inventory, I sit and I can, or let me think of a better way to say this. I should do this before the video. There are several use cases we've got, right? I want to pull an item out of the merchant's inventory. I want to check the quantity. I want to just see if the item's there, right? In an array, you have to do a lot of looping. It's annoying. In this, I just have to say something to the effect of inventory dot get, or key exists, right? And that'll tell me if that type of item, if that merchant has that type of item. It's one call, which is before I had to loop through the array, which was a pain. I can also say inventory dot get, and that gives me the quantity. Now, I do have to put in some management around this to say that once an item type's quantity decreases to 0, you remove it from the map. But that's a little bit easier to use. So this is going to decomplicate my code, which is really nice because I want the data structures to be simple because the algorithms are not, as it turns out. The other thing I'm doing while we are here is I am adding another class to simplify things. Whoops, I don't need that. Whoops. let me do this the right way. Don't you love live demos? I'm going to add another class here called offer. And this is just a convenience thing. It's got a player item, and this is an item type. And by the way, I may go and in the new world rename item types to just items. It might make sense. And it would be less verbose. We'll see. And then I've got player quantity, and this is an int. And then I do the same thing for the merchant. And this is just a convenience class because before I was returning items, and sometimes when I created an item, the quantity meant the quantity being offered for in the trade, and other times the quantity meant the amount that entity had total, which was probably a bad practice from the start. So this is kind of the type, well, actually, in order to complete this, I should show another relationship that says, hey, this offer contains, you know, some of these item types. So that's what I'm up to. I also did a lot of theory work around trading, which I'll probably save for a Mechanical Monday to go through because it's kind of abstract and I really need to organize these notes before I blurt them out all over YouTube. So anyways, that's what I've been up to. Look forward to seeing your video. And next week, I will be traveling to Canada, so I should be able to get a video on Sunday, but it'll depend on when I get back. It may be a snitch late. So, anyways, as always, I remain faithfully your brother.